Hello everyone, Mr. Schultz here, and we are going to jump into 8.3, Analyzing Population Data. So make sure you fill at the top right here, your name, your period, as well as the end of lesson reflection. Do you somewhat get it, or can you teach people, or somewhere in between? Now, make sure, I want you to give me one sentence, one or two, or even three sentences explaining this lesson. Let's go on. Make sure you have your handy dandy XP pen or other writing tablet because we are going to need to write today. So, we'll often describe data and graphs from the measures of their centers or the measures of their spread. That basically means, where is most of the data and how far away from that center is it? So, how can we present this? Now, there's two normal ways we present this. The theoretical frequency, this distribution, the theoretical frequency of each possible data value presented in, two main ways is tables and graphs. And we're going to show you both of these in just a little bit, but just a little heads up for you. So normally, the mean is a great center tool to use to describe, hey, this is the center. But when the data is skewed, it might not be reliable. So if you ever find a pole that's kind of bent or skewed to one side, just think about that. So here's some examples of us naming some distributions. We have the symmetric distribution. This is where the mean and the median are, about equal. And the data is pretty much symmetrical. Left side equals right side, symmetrical. Now, when we have negative distribution, that's when the median is greater than the mean. And less of the data is on the left side. Positively skewed is going to be when less data is on the right side, and this is when the mean is greater than the median. Just think of it like this. Here's the question. The basic question is, where is the majority of the data, or where is the most of the data? So right here, we got the center. For the symmetric, let's scoot up. For negatively, it's going to be on the right side. Positively, it's going to be on the left side. Now you can see that each one of these has tails, like trailing data. The center is left and right. Negative has a tail going to the left. Positive has a tail going to the right. Let's go on. So here's a better way of looking at it right here. See, we have this left skewed and it's negative skewness. That means, hey, less data is on the left. Less data, so it's left skewed. More of the data is on the right. Right skewed, right error, right something is positive skewness. Skew could be there's an error here. What's the error? Well, it's on the positive side or the right side. It's on the left side. Left, there's like an error in the left side or the negative skewedness right there. All right, what about bimodal distribution? Hey, quick, how many wheels does a bicycle have? It has two. So bimodal distribution is when we have distribution where we have two modes. So two modes right here. Like here's the mode. And we're like mode. And here's the mode right here, mode. And so it's when we have two separate groupings of data. So we could go right here and we could be like, all right, this is where, two separate groupings of data. And like the best way we could, in order to describe it, state it is bimodal. Then what we should do, describe each group. Let's go on. This last vocabulary term we're going to talk about is outlier. Outlier is great. Sometimes you want to be an outlier. You want to be the diamond in the rough. Quick, what movie is that from? Go ahead in the comments and tell me. Diamond in the rough. Iago. So right here, we got this guy and we got this guy. It's all of a sudden there's something different in our data that doesn't match what we think would happen. Like, hey, if this is at 6,000, a power level of 6,000, well, it should be like more over here, but it's not. So it's changing our data somehow. So, for example, if something is less, something is less, then it's going to pull down the average. If something is more, it's going to pull up the average. So, here's a question. Why is the mean age of our class 22, even though the average age is like 17 or 16? Let's go on. Go ahead and answer that question. So, we are now going to figure out mean and standard deviation. Standard deviation is important later, especially when we're talking about empirical rules and all that jazz. But the mean of a population looks like this funky little symbol right here. It's like a U. And this is going to be the mean. So I'm going to pause right here and I'm going to show you my work. The first thing we are going to do is we're going to add all of the numbers. So basically they're asking, and this guy, they're asking, hey, what is the mean? So if we add up all the numbers and then we divide by the total number, or no, the how many of them there are, we're going to get 9.9. So that's the mean. Now we are going to figure out the standard deviation. This is kind of like the mean of the mean, but shh, let's hold up. All right, so to find the standard deviation, this is where we're going to find the squares of the difference between the mean and the numbers. So every single time we're going to subtract 9.9 by our numbers we have. So we're going to have 9 of these equations, 9.9, 9.9, 9.9, 9.9, all the way to 9. So I got 1, 2, 3, 4, 5, and I'll do it right here. 1, 2, 3, 4. Now I have the mean. Oh, let me erase that. Now I have the mean, but what I got to do now is I have to find the difference. Hey, what's the difference between 10 and 9? The answer is 1. So what's the difference between the standard deviation and each of these numbers? But you also have to square it. So now we just write this out and we square it. And we do 9.9 minus 12. And then we square it. And then we do 9.9 minus 8. But we square it. And we do 9.9 minus 9. But we square it. So we're finding each one of these. So I'm going to do this now, and then I'm going to show each of the answers or solutions in 3, 2, 1. Okay, guys, so this is all the result. Now, this is a very important time to tell you, guess what? You need to use a calculator, okay? Please use a calculator. Now, If I add these all up, I'm going to get 54.89. So I added the sum of all the squares of the differences. Now I'm going to divide by 9. I'm going to get the variance, and that's going to be 6.1. So what did we do? We, just like we did the mean, we added and then we added the sum. So we added the sum and then we divided by the total number. But what did we do to each of these numbers? It involves an exponent. And a shape, it looks like a shape. We squared it. So now what we need to do is we need to find the square root. So we did stuff and then we were bringing it back. We're like, all right, we're going to square it and then we're going to add them up and then we're going to divide, then we're going to, so we just need to find the square root of 6.1, which will be about, 2.5. So this is the standard deviation. Now I'm going to tell you right now, for the most part, you'll probably get like one of these questions and that's it. You're not going to get like a worksheet of 100 of these problems because it takes too darn long. So let's go on. Let's show you how we can do it mathematically. If you don't have a graphing calculator, which you should, there's a way around it. So what we're going to do is we're going to scroll down and let's determine the mean and the standard deviation by computer. So we're going to do that in 3, 2, 1. All right. So what you're going to want to do is you're going to take the data, capture the data. Either you're going to type it all out or you're going to do what you guys know how to do best. And I do as well, copy paste. So you're going to take this data and then you're going to do the following. You're going to have a list. So let's move this guy over here. Say, get over there. L equals brackets, square brackets. This is saying, hey, I have a list. And this right here is, hey, I want you to find the mean of that list. And then 3 right here is, hey, I need you to find the standard deviation of list L. We have 2 commands. This is like programming right here. I want you to find the list L mean, and I want you to find list L standard deviation. So remember how we just had all that information and we had to do it by hand to find each one? Watch this. It's this simple. Put the information in and it pops it right out. So what I'm going to do and what I want you to do is if you're using Desmos, then I would suggest, and if you are struggling, you want additional help, ask me or ask another person, and we will help you in class to copy paste this. So I'm going to copy, paste. Now I just go back. I can put it right here. Ta-da! I don't even have to do any work. It's right there. That's it. Done. So let's go on. So compare the distributions in mean and standard deviations with mean and standard deviations. Okay. So the 2 things I'm going to do is I'm going to find the means of both. I'm going to find the standard deviations of both. And then I can describe and compare them. That's it. So rather than show you that I'm going to type each one of these out, I'm just going to put the data into Desmos on my own time, and then I'll copy and paste the results. And then we can write some sentences on it. So we'll come back to this in 3. Well, we'll go to the Desmos first. 2, 1. All right, guys. So as you can tell, I just put the data into Desmos. And then I copied G2. I put it where geometry class 2 was. G It's the information from the geometry class 1. So now I'm going to go dive deeper into this and talk about it. So now I'm going to look at it. So now I can type it up. Now the means are 86 and 77. So I can literally state geometry class 1 has a higher center. Why? Because the mean, which we normally say is the center, is higher. It's larger. But it looks like standard deviation is how far is it spreading? How far is it spreading? So in one standard deviation, it's going to go up 14 or down 14.09. It looks like geometry class 2 has a higher standard deviation. Now, if we were going to put opinions on this, we'd probably say, hey, I'd rather be in geometry class 1. The mean is higher and the data is closer together because the standard deviation is smaller by 3 points, but that is smaller. So that's our lesson for today. I hope you guys have a wonderful day. Bye, guys.